So numbers in programming are important, and you have an activity here 2.2, which is about this converting uh, one currency to another currency, asking about the exchange rate. Right. So you have this activity 2.2. You need to complete this activity here. Once you got the euros, fine, you got the exchange rate. Now what is the amount after conversion that you need to display here? So how do you do that? Is that you need to multiply the number of euros, the euro value, with the exchange rate to get it. For example, here, if you want to convert the Kuwaiti dinar to dollar, we say what is the exchange rate and how many Kuwaiti dinar you want to exchange. 300 into 3.15. We multiply it to get the exchange. Fine. Sometimes the exchange is not free. We need to pay the commission also for the exchange. So you need to deduce the commission. Exchange rate, how many euros you want to exchange, and what is the commission you are going to pay in pound. So you reduce that exchange from that commission from the pounds, minus it, and then you multiply that with the exchange rate, or you multiply euro with the exchange rate, you get the pounds minus the commission in pounds. Fine. So that's the number system we have. Now in solving, when nesting numbers blocks, it is important to ensure the calculations are carried out in the right order. Okay. So because we have multiplication, division, addition, subtraction, we must know the precedence, the operator precedence. I think you have studied this in mathematics. Is it right? You have studied this in mathematics, operator precedence. Yeah. So if you have uh, multiplication, division, which comes the first, and plus minus comes the next, right? So basically we follow the operator precedence of this bracket, indices, then division, multiplication, addition, subtraction. Bracket, indices. Indices here, it means the power, like 2 power 2, 2 power 3. Fine. Then division, multiplication, and addition. So if you do, for example, this example, 2 plus 7 divided by 5. 2 plus 7 divided by 5. What is the result? What is the value of this expression? 2 plus 7 divided by 5. 3.4. 5.5 or 3.4? The operator precedence, you need to follow the operator precedence, right? First you divide this, it will be 1.4, right? Plus 2, then you add it, so it is 3.4. So we need to understand the operator precedence. To make it more easy, you can say something like this: 2 plus 7 divided by 5. It will be more clear. Or if you want to do 2 plus 7 first, then you have to put this in the bracket, then divided by 5. So it will be 9 divided by 5, okay, which will be like 1.8, which is 1.8. Right. So we look into these things. First we look into the brackets, then we look into the indices, that is the power, like x power 2, something like this. Then we look into multiplication or division, then addition and subtraction. Okay, it's okay, no problem. Fine. So you have an activity 2.3 for this. You can look into this activity 2.3. Fine. So here is in the next about rounding constant and comments, rounding of numbers. Fine. So rounding of numbers, we all know that how we are or we do the rounding of numbers, or how the rounding is done in mathematics. Fine. So there is a rule for rounding the numbers. If next digit along the decimal place we are rounding to it is less than 5, then we round it down. And if it is more than 5, we round it up. So for example, if you have this value 129.834 and you want to round it to one decimal point, one decimal place, 129.1 value you want to keep. So that value will be 8 only, 83. So why we remove the 3 is that 3 is less than 5. Anything less than 5 will be, yeah, less than 5, very good. Anything less than 5 will be rounded to the same value. And if it is greater than 5, for example, we want to make this as 3.2 decimal places. 3.768. So if you want to remove the 8 1, then 6 will become 7 because it is greater than 5. Similarly, if you want to round it to the number, whole number 133 point, then we'll see what is the after the point. 5 or more or less than 5. If it is less than 5, it is 133. If it is more than 5 or 5, it is 134. Right? So in OUBuild, we have this function called round that will do the rounding of the numbers in OUBuild. That's about the rounding of numbers. Constants, constant is stored in a variable, but the value of the variable will not change during the running of the program. When the program runs, the value remains constant, will not change. Constant typically use capital letters in naming the constants, and it holds unchanged data which will not change frequently. Like for example, pi, pi. You know the pi value? What is the pi value? 3.14159, and this is constant value, right? This is constant value, right? So pi is fixed value or a constant value. So in this case, we can create a constant variable where we can store this pi value and it remains fixed, it remains unchanged. Fine. So that's why that's where it comes to constant values or fixed data. So a constant represents a fixed data that is known to the programmer while creating the program, and hence it can be built into the program. Code that is largely self-explanatory using variables with meaningful names, sometimes referred as self-documenting, which means that that code which is self-explanatory and it does not require any comments to explain the program. What is the program? Any program that is self-explanatory, it means that if you read the program, you will understand what is the program. That is what the self-explanatory. So such programs, because we have that, we refer it as in self-documenting. The programs are self-documented. Right. So that self-documented programs. If not self-documented, we can also create the documentation. We can write some comments in the programs. Comments provide the human reader of code with explanation. Comments are for explanation, to explain the program. Comments are not for execution. Comments are explanation to the program. It provides an explanation about what is the program, so that whenever we want to read the program, we can read its comments and we try to understand what is the program is. That is what the comment is. Okay. They increase the readability of the program and help in maintenance of the program. Okay. So any programming language or even the OUBuild ignores the running of the comments. The running of the comments are not executed. That's what it means. So comments are used to make documentation, to give explanation to the program, what is the program and how the program executes, or what you are doing inside the program, these kind of things. The next comes the maintenance. It's about keeping the program useful and helpful and correct and improving its performance. That's what the maintenance here is. जीवन भाई सलाम। हाँ हाँ उधर ही होगा। मैं नंबर भेजा ना आपको, कॉन्टैक्ट नंबर उसका, उसको फ़ोन करके जाओ। 5 किलो उसके पास बर्नी ले लो और थोड़ा सैंपल भी ले लो। 5 किलो ले लो और थोड़ा सैंपल भी ले लो। थोड़ा अच्छा वाला देख के बड़ा वाला ही लो, यानी वो 20 रियाल के अंदर का होना चाहिए, ज़्यादा नहीं होना चाहिए। ठीक है, पता नहीं, वो बताया नहीं, वो बोला मैं अच्छे रेट में देगा, देख लो। 20 के अंदर होगा तो ले लो। हाँ हाँ ठीक है। So that's about the maintenance, that is keeping the program on the right track, what is called the maintenance of the program, checking its performance, that making sure that there is no errors during the running of the program. So maintenance goes long period than the development, right? Once we develop the program, we leave the program for use. Like for example, you develop any mobile application, you upload this mobile application on Google Apple Store, or you can upload this on Google Play Store. There people start using them, right? Let's say you develop this in 6 months and it is in use for 5 years. So in these 5 years, you will be working on the program as maintenance of the program. So sometimes maintenance takes long time, okay, it go for a long period of time compared to the development. Fine. So this is about the maintenance of any program. Okay, the next we have is about strings. The strings, what is a string? It's a set of characters. String is nothing but a set of characters. It makes the string. So we can visualize the string as we see here, a set of characters. Every character has an index, that is the position of the character. Index is nothing but position of the character. We have a function called join in OUBuild that is used to join two strings. Used to join two strings. Right. For example, here join of hello name. So it will be hello. If the name has a value Muhammad, then it is hello Muhammad. Right. We can see that in the in what is in the OU build. Right. So let's start with an event. For example, a flag is pressed. We say hello. Say enter your name. We ask the user to enter the name, and then sorry, it's here. Not say. Delete this. We ask the user, what's your name? Fine. So we take a data. Let's say we take the data as variable as name. Fine. We set the name to the answer because answer has whatever we enter. Fine. Then we say by join. Okay. We have the operators here. Join the operators. Hello name. Okay. And we say this. Hello Muhammad for 2 seconds, whatever we enter the name. So join is going to join this text hello with the name. Name is set as the answer to this question. Okay, so this question is asked. When you click this one, this question is asked and it is waiting for you to answer this here. It's waiting for you to answer this here. Increase the font. Yeah. So it is waiting for you to answer the question here. For example, hello, enter the name. It says we enter the name. Fine. Now it says, sorry. So it says hello Muhammad for 2 seconds. Let's keep it for 5 seconds so that we can see it. We click on the flag. It says enter your name. Say Muhammad. Say hello Muhammad. So this join, what we see here, joins the two strings. Joins two strings. Okay. Also, if you join two numbers, that is also considered as a string. Okay. For example, join 1, 2, 3, 4. So it will be 1, 2, 3, 4 because it is joining the strings. 1, 2 is considered as a string. 3, 4 is considered as a string. So it is joining the strings. Plus is the one to add strings. Join is to join the strings. Sorry, plus is to add the numbers to perform calculations. So if you want to add or perform calculations, then you use the plus operator from the OUBuild. You have this plus operator, this one. Okay, and if you want to join two strings, then you're going to use join here. Strings or join numbers, you use join here. Okay. The string also have many different type of methods. For example, it has this letter of method. This reports character at a particular position in a string. For example, if you want to say at letter 1 of the message, if the message is welcome to TM111, what is the first character in this message? It is W. So this will give you W. Length of the message, it will give you the length of the message, the length of the string. Length of the string means length of the string here, it means the number of characters. Okay, now the first character, there is a question here, 1 would be the first or 0? No, the first character is represented. The index of the first character is 1, not 0. In OUBuild, the index starts from 1, not from 0. I know it may be confusing for you with other languages like Java or C Sharp. There, the index starts from 0. But here in OUBuild, we keep the index from 1. So here the index starts from 1. So welcome W is at the first index, E is at the second index, L third index, C fourth index, and so on. Okay, length will give you the number of characters, including the spaces. So you count the number of characters is 16. Okay. So incremental construction, join inside join. We can also use this join inside join and let the blocks inside the blocks. Fine, as you see here, join of letter, okay, with from this message. Okay, again here is inner join. So you can include join inside another join to join more than one string. To join more than one string, join include another join. There is a question, is the space countable as a character? Yes, space is also counted as a character. Space is also counted as characters. Okay, fine. To have more on this, I will look into these activities 2.7 and 2.9 to know more about the strings and its blocks and its functions. Okay. Here is an example program by using that is demonstrating joins. Okay. This program is it will have a message, welcome to TM111, what's your name, then you enter your name, then what's your home country, you enter the country, then it has a message, good to meet you, and all the best programmers come from that country. So this demonstrates the join here, as we did here. Right, so you ask some questions here. Fine, use the join to join the answer with the proper message that will be displayed. For example, here, what's your name? You enter the name, you join the name, it's hello, the name. Okay, again you ask, what's your country name? What's your country name? So we take another variable, let's say country. Okay. Now we set the country to answer from the sensing. We get the answer. We set it here. Okay. Now we say the message again. For example, say join from the operators. Join the country with the name and say that. So what's your name? Muhammad. Hello Muhammad for 5 seconds. Then what's your country name? India. Then it says India Muhammad. Just to demonstrate the join. TM103, no, sorry, this is not TM103, this is TM111. And TM103 was from 2 to 4. من 2 كان من 2 اليوم. خلصنا هذا محاضرة بتاع TM111. This is another program of converting the currency. Fine. So here also we see that we use the operator, okay, multiplication, and we use the join to display the dollars. Fine. You can try these two programs back at home. So that's about variables and the strings. So what we discuss is about variables and strings. The next we have list and custom blocks. Lists are nothing but a set of data. Lists are nothing but a set of data or a group of data. Fine. So data in form of numbers or a string can be stored in a variable. At any given time, a single variable can store only one item of data, or it can store only one value. So a list can store many items of data at a time of similar type of data. List can store many different similar type of data at any time. So whenever you want to store a set of data of same type, we can use a list there. We can use list there. So a list can store many items of data at a time. A list may hold any kind of data. It can hold numbers, it can hold strings. Item can be added to the list. It can be removed from the list during the running of the program. A list can be visualized as a sequence of slots. For example, like this, something like this. A list of birds. Okay. The slots are numbered from 1 to n. Okay. A list can be empty when it is created. You can add later the values to the list one after the other. Fine. So you can see on the screen the list. For example, the list of birds here. Okay. When you create a list, you can create a list from in the OUBuild by from this option, make a list. In data, make a list. For example, birds. Okay, so you got the list here, an empty list with a length 0. Length 0, it means that there is no elements in the list, or there is no data item in the list. Fine. So here is an add option where you can add the thing to the list. Fine. You can also delete this one. You say delete one of the birds. It means delete the first item or first item of data from the list. That is the delete option here is. Okay. Some of the key blocks for the programming with the list is shown here. Adding an item to the list by using add, deleting an item from the list, inserting item at a particular position, at first position, at second position, and third position, and so on. Okay, so inserting item at particular position, replace item at particular position in the list, display the item at particular position of the list, length of the list, length of the list, that is how many items or how many elements are there in the list, that will give you the length of the list. So simply you can see here, let's say that, let me delete this. You have the list here. add example, add a item to the list. Okay, the list is birds. Let's say that we add a cow, sorry, birds it is, peacock, we add a peacock. Then again we want to add one more, you can add, let's say parrot, fine. And if you want to show the length of the birds, okay, you can say the length of the birds, say length of the birds, or with a message, you can also say with a message by using join here, join the number of birds in the list is the length of the list, okay, that you can see here. So when I click this one, you see two lists are added and the number is shown. Number is 4 now. Okay. We can also delete here, delete the bird, delete one of the bird. This will delete the first one. You can see the first one will be deleted. Fine. Delete if you want to delete, let's say not the first one but say last or all. Fine. So you can say this 7 items are all are deleted. Fine. So you have all these options when you are dealing with the lists. Add to block is used to add bird or an item to the list. Similarly, we can also add the blank over here. Fine. Length of will give you the number of items in the list. Item of block will give you what is the item at a specified position. What is the item at number 2? What is the item at number 3? Okay, that can be given by the item. Fine. And then delete of, delete a particular item at a specified position. Insert add of the block. Now this block will help you to insert an item at a specified position in the list. Okay, at a specified position. Fine, at second position or third position or fifth position, something like this. Replace will help you to replace any item at particular position. Delete will also help you to delete an item at a position. Fine, you can delete one or delete all or delete, okay, a position item. So here is an exercise. Given a list course as shown in the figure 10, report the following. Item 3 of courses. So what is item 3 of courses? Here. Item 3 of courses. What will be the item 3 of courses here? TM111. Good. TM111. Insert item, insert TM112 at 4 of courses. So where TM112 will go? TM112 will go at which position? Number 4. So it will come here, TM112. Okay. Replace item 8 of course with M105. So which course code will be replaced here? Which course code will be replaced? M269. So this will be replaced by M105. Okay, so after running all blocks in the sequence at once, what will the course look like? So this will look like something like this, right? With M129, EL111, DM111, DM112, M131, M132, and 7th is block, and 8th is M105. Okay, fine. So that's about the list. Now let's have a look into similarities between strings and list. A string consists of sequence of character, whereas a list consists of sequence of items. Fine. Each character or item can be accessed by using its position. Both the characters and the items will have the same position starting from 1. Both have the length. The length of a list is the number of items in the list, and length of a string is number of characters in a string. We also have the differences. You can insert an item into a specified position within a list, but there is no block to insert a character into a string. Right? So there is no block to insert a character to a particular string. So as a self-assessment, you have to do these activities. Activity 2.11, 1 to 13, fine, and 2.14. These activities will help you to to explore more on strings and lists. Fine. Whatever the activities you have in this part 2, fine. You go through those activities one by one. Those will explore you more about the numbers, strings, and the lists, how to use them, and what are the different blocks, functions they have, you know, those things. These activities are all OUBuild programs. These activities are all OUBuild programs that you are gonna apply that. Fine. We'll also discuss, inshallah, these activities in our lab session on Thursday. As we all know that we have the lab session on Thursday. What time it is? Do you remember what is the time of the lab session on Thursday? It's from 2 to 3. Okay, so that's about the numbers, strings, and the list, and how we use them in the OUBuild. Fine. Yes, Mr. Muhammad, we have every week we have a lab session on Thursday. Kindly check your timetable in the SAS. Okay, fine. That's about the numbers, strings, and the lists. Do you have any question on these numbers, list, and the strings? Students, do you have any questions on this number, list, and strings? Okay, thank you. Okay, our next topic here in this meeting is from ideas to programs, like how we write a program for any given problem or for any given question, or let's say it's better to say problem, right? Because we write the programs to solve any problem. Programs are written to solve any problem. So how we take that problem and convert that into a program, or make a program of that problem. So that's what we say program specification. Typically arise from the problem which might be expressed in English, such as how do I calculate a price of a ticket, or how do I calculate a price of a product if I am buying a set of products. Okay, so here comes we need to think of problem solving. So problem solving in the context of programming involves working from a specification to the implementation of the problem into a program, testing the program, debugging the program, and running the program. So for any given problem, we try to solve the problem first. Okay, we try to express the problem as steps that gives us the solution to the problem. So we have something called algorithms here, that is considered as a step-by-step instruction to solve any problem. So algorithms are nothing but a step-by-step instructions to solve any problem. So to create a program, we need to have the step-by-step solution, and we apply those step-by-step solution in programs. We apply those step-by-step solution in program to write a program. So that means that first we write an algorithm for any problem, and we use that algorithm to write a program. We use that algorithm to write a program. So to write any program, to write any algorithm, we need to understand the problem, and we need to understand the steps in solving the problem. Let's say, for example, we want to add two numbers. Fine. Let's say that we want to add two numbers. So this is a problem, adding two numbers. It's called addition problem. So this addition problem, to solve the addition problem, what are the steps we need? Right? Can you give me steps that we need to add two numbers? Let's say that we want to add x and y. Let's say x is 2 and y is 3. We want to add these two numbers and display the result. So what are the steps that is required in this case, that we can say as an algorithm? Create two variables, then after creating two variables, write x, then write y, and then sum x and y. Right here you mean read x, then read y, then sum x and y. So we write the steps. Step number 1, read x or input x. Step number 2, read y or input y. Step number 3, sum x and y or x plus y. Step number 4, display sum. Something like this. Okay. So you see that we can have different algorithms for any specific problem. It depends on the person who is writing the algorithm or who is writing the steps. Okay. Some says read x, some says input x. Fine. Some says display sum, some says display or result, some says output result. So there is no fixed thing in writing algorithms, but the only thing is that the steps should be clear and in proper order. First we read the value, then we find the sum, then we display the sum. The order should be proper. Fine. But writing, you can write in your words, okay, using some correct definitions. Fine. That's the algorithm. That makes the algorithm. Fine. So it's a skill to, or it is considered as a skill, to write or to develop algorithms from the given problem. So taking the problem solving process in two stages, designing and implementation, makes things more simple. Designing an algorithm, then implementing a program. For example, you take multiply number of full price tickets by full ticket price, or set total for full price to number of full price tickets multiplied by full ticket price. Okay. So there is number of tickets and we know the price of a ticket, multiply them and set that as a price. Okay. That's what here it means. Fine. So we can break this process into steps. First we design the algorithm and we use that algorithm to implement the program, to write the program. Now we also have something called testing the program. After we write the program, we need to make testing, of course. So acceptance testing is a key stage in any software. A client will not accept a new software until it passes the acceptance testing. Acceptance testing, it means that the software will undergo a set of testing to convince the client about the correctness of the software and to use the software. So we can set a number of tests for the acceptance testing. For example, here let's say that we have the program of calculating the total price of tickets, calculating the total price of the tickets. So in this case, we test if there is no tickets, number of tickets is 0, number of concessionaire tickets 0, total price must be 0. So we check it, we give the number of full price ticket 0, concessionary price ticket 0, result is 0. Only one full price ticket, concessionary price 0, result must be 8 if it is ticket price is 8. Only one concessionary, it is 6.5 if the concessionary ticket is 6.5. One full price ticket, one concessionary price ticket, so it is 8 plus 6.5, 14.5, and so on. So we need to test, we need to give the values and test the output. We check the output, what is the output, whether we are getting the correct results or not. If you are getting the correct results, you are getting the correct output, okay, you are passing the tests, your program is passing those tests. And if you are not getting the correct results, correct output, then there is some problem inside this program and you need to check that problem. Where is the problem, what is the problem, how we can solve the problem. So in trying to trace and fix the problems, that is what we call the bugs, the problems or the errors or the mistakes inside the program. So it is useful to bear in mind common errors that tends to be made in sort of programming. Okay. For example, incorrect data stored. Sometimes we store the incorrect data. That let's say that we store the price of a ticket which is an incorrect price. That will also lead into incorrect result. Sometimes we store the data in wrong variables. We store data in one variable and we are using another variable. This can also be a chance that can bring the error. Sometimes incorrect variables are used in calculations. So we need to make sure that we have the right variables used in our programs that has the data. Wrong number blocks used, for example, to add, or so let's say that we need multiplication but we use plus. Okay. Sometimes we implement the steps in wrong order. Sometimes we do some wrong initialization to the variables. Okay. Sometimes it is incorrect nesting of calculations. So like we need to do first, for example, 2 plus 3, then multiply by 7, let's say, something like this. Then we did something wrong. We did not put the bracket. We just said 2 plus 3 multiplied by 7. Now then we get a different result. 2 plus 3 is 5. 5 multiplied by 7 is 35. Whereas this is 21 plus 2, that is 23. So we have different results. So these are the common mistakes that can appear in a program. So we need to be careful in writing these programs, and when we test the program, if we find any mistakes, if we find any errors or bugs inside the program, okay, we need to go back to the program and check the program where the things are wrong, and we need to correct those programs. Okay, here is an example of this. In a particular supermarket, the normal price of 1.5-liter bottle of cola is €2. However, sometimes there is also a special offer on the same. A program is required to ask the user the condition of the special offer, how many bottles the offer involves, and the volume of each bottle in the offer, and then to tell the user difference price per liter between the special offer and the normal offer, so the user can decide to buy the normal or the special offer product. Okay, so this is a problem. This is a problem. The problem is that there is a cola bottle which is of €2, but sometimes there is an offer on cola. Okay, so we say that for here the program is to ask the user that how many liters he want to buy, how many bottles he want to buy. Okay, and it check for which one to purchase, which is the better to purchase, whether the offered one or the base price one. Okay, which is the best to purchase. Now in designing algorithm for this problem, first we need to ask what data is needed in this problem. First we need to ask ourselves, like, what data is needed in this problem. Okay, so what is the data needed in this problem? Can you guess what is the data needed in this problem to do any program? Yes, students online, can you guess what data is required in this? Anyone? A bit confused. Okay, I explain the problem. This is a problem of supermarket. A supermarket has a normal price of 1.5 liter of cola is €2. Okay, sometimes there is an offer on the same brand of cola. Now we need a program is required to ask the user conditions of special offer, that the price of the special offer, how many bottles the offer involves, the volume of each bottle in the offer. Let's say for example the price of the offer is 1.5 euro. In the offer it includes 2 bottles. Every bottle is of 1 liter. Okay, and then tell the user the difference in price per liter between the special offer and the normal offer. Normal offer is 2 euro and the special offer is what? Okay, so that the user can decide which one to buy, whether the normal one or the special offer one, based on his requirement. Now in this case we need the data from this problem. What we need is the price of a special offer, number of bottles a special offer can give us, and the volume of each bottle in the special offer. Let's say price is 1.5 euro and we can purchase 3 bottles and every bottle is of 1 liter. Okay, we have some data that is normal price and normal volume. Normal price is 2 euro and normal volume is 1.5 liter. This is fixed data what we have. Okay, next what more precisely is required? Calculate the difference between the normal price and the special price. Okay, between the normal price and round it to a nearest value. Now write down the first draft of the algorithm. First, what we need: input the price of a special offer, then input number of bottles, then input volume of bottle in a special offer. Now calculate the difference: special offer price per liter minus normal offer price per liter, rounded to the nearest value and output the nearest value. Okay, now special offer per liter, different people might do this slide in a different way, because as I said in the beginning when we discussed the algorithm different people write in a different way, right? So there is no fixed thing that you have to follow in writing the algorithm. Only thing is that the steps must be clear and must be in order, but you can solve it in different way. You can solve it in different way. One of the way is to solve the problem is this one. Fine. Or you can write it in your own way, like how you solve the problem. Fine. So we write the steps here. We make all the calculations here and we print the difference here. Input the special price offer, input the number of bottles, volume of the bottles, calculate the special offer per liter, normal offer per liter, subtract the special minus the normal, see the difference and place the difference. What is the difference from the normal to the special offer? Fine. So this can be one of the algorithm in this to find the difference between the special offer and the normal offer. Fine. Now we wrote the algorithm. This is the algorithm. Now we want to implement this algorithm. And the next step to implement the algorithm is first we take the variables. Okay. So we take the variable special price, number of bottles, volume of the bottle. We take the normal price variable. Yeah, declarations. Good. It's a declaration of the variable. Special price, difference price. Okay, you can check this in this activity 2.17. So we declare all these variables. Then we go to the activity. We ask the user to enter the special price. What is the special price? How many bottles? What is the volume of the bottle? Yeah, then we set these values. Fine, we calculate the difference and we display the difference. Okay, which is this, and this activity is 2.18 and 19 from the activities. Fine. So it's better you try this problem back at home in the OUBuild based on this algorithm. Based on this algorithm, try this problem, okay, and see or print the difference between the normal price and the offered price. Fine. So this is what we have for today to discuss uh, in this meeting number 2 of TM 111.